All right, good evening. So we're going to do some more college algebra tonight. We're going to talk about the vertex formula. I've got my trusty TA here, so she's in a bad mood, so that's going to be good. But, hopefully, yeah, well, we'll see about that. All right. All right. So we're going to talk about the vertex formula. All right. And this is how to find the vertex in a slightly different way, because who wants to go through find and complete the square every time you want to do this? Okay. So please, if you need to skip past this because you really don't want to know, I get it, but this is why the formula works, and this is why we have the value we do. So say, for example, right, we have y is equal to ax squared plus bx plus c. Okay. What we're going to do is we're going to pretend like we're going to complete the square on this. Okay, I promise you don't have to do this. Okay, you can watch me do it once and you'll never have to look at this again unless you decide to become a math teacher. Okay, so all I did is I factored out an a. Right? If I multiply this back in, this is what we get. Now remember, right, this was the first step. We're going to set up the form, right? Set up form. The second thing was we were going to identify that middle term and come up with like that magic number we're going to add and subtract. So this is the identify middle term. So I'm going to use a capital. I'm going to say b is equal to, what's my middle term? B over a. Right, and then we took b over 2, 1/2 times, right? That's 1 over 2 is the same as 1/2, so it's 1/2 times b over a. So we get b over 2a. Remember, this is what we've used to factor to. And then we square. Okay, and that's going to be b over 2a squared, which is b squared over 4a squared. We really aren't going to care too much about this value. Okay, we're not going to, we'll write it down because we have to keep it, strict, but we're never going to come back and visit. You're not memorizing this. Okay, so we're going to say this is y is equal to a. Okay, we have our x squared plus b over a x, right? And then we have plus b squared over 4a squared minus b squared over 4a squared, yeah? Plus c, all right? And then do you remember, like when we wanted to factor this, right? It always factored into a very specific form, all right? And that's what this is right here. So this is y is equal to a, parentheses, and then I've got an x plus b over 2a, all right, squared, and then this is minus b squared over 4a squared, okay, plus c. Okay, you're doing much better today. All right, now we are going to factor, right, we're going to distribute that in. So we have a x plus b over 2a squared minus b squared over 4a, because one of these cancels, and then plus c. Now I'm going to go ahead and stop right there. All right. So to get our vertex here, right, this was a x minus a negative b over 2a squared minus b squared over 4a plus c. And if you remember, right, the vertex was this piece here and then the rest, all right? So my vertex was negative b over 2a and then that stuff, okay? We're going to come up with this way. We're going to come up with this value in a different way. But the x value for my vertex, right? So the x value for vertex is x is equal to negative b over 2a. And that's the formula you want to deal with, okay? Now, I'm sorry, you have to memorize this little formula for the vertex until you get to calculus, all right? Even when I was in your chairs, I resented the fact that I had to memorize this formula because it was like, there has to be a better way. And unfortunately, like, oh, you got the calculus. I'm like, hey, there's a better way. Like, great, I spent 2 years of my life memorizing this ridiculous thing. So I'm sorry, that's just the way it is, but there we go. All right. But that's an important result, okay? So what we're going to do is we're going to plug this in, and we're going to say, well, f of negative b over 2a, right, for my function y equals f of x, and this is the y value of the vertex. It is not nearly as difficult as what it looks like right here. Okay, we are going to have actual numbers to plug in here. We're going to be able to do arithmetic. We're going to be able to get values. None of this is going to look nearly as hard as it looks right now. And to show that, let's do an example. Okay, so what we're going to do is we're going to say, okay, here's y is equal to x squared plus 8x minus 1. Now, this would not be a terrible position to be in, right? If I had to complete the square on this, it wouldn't be the end of me. I could do it. I never liked doing complete the square, but you know, it's not going to be the end of the world. So my vertex, right, is x is equal to negative b over 2a. If you need to memorize this formula, and you do, I suggest write it down as often as you're going to use it. Okay, what's my b? A, right? This negative b over 2 times, what's my a? A is 1, right? Because every time, right, it's always in the form ax squared plus bx plus c. Okay, so the a is 1, the b is 8, the c is minus 1. Okay, this formula doesn't care about c, so there we are. So this is negative 8 over 2. This is negative 4. Okay, that's the x part of my vertex. Now, how do we get the y? Well, we plug in x equals negative 4. So we say y is equal to, right, negative 4 squared plus 8 times negative 4 minus 1. See, I told you it wasn't going to be as bad as it looked, right? This is much easier to deal with. So negative squared is going to be a positive number. I don't care what your calculator tells you. Okay, minus 32 minus 1. Okay, 16 minus 32 is negative 16. 16 minus 1 is going to be negative 17. So my vertex is negative 4, negative 17. Everything else works exactly the same way. If they asked us for the intercepts, right? What's the X-intercept? All right. So our formula, right? We have y is equal to x squared, right, plus 8x minus 1. Okay. And we have to set this equal to 0 and solve for x. Well, you're not factoring this. I don't have a completed square to work through this. So we could say, you know, if only there was some kind of a formula that let us solve quadratics. Yeah, if only something like that existed. Wait, I got it. Right, quadratic formula. Yeah, they have one for us. Again, you have to memorize this thing, and I'm sorry. It comes up a lot when you're dealing with a lot of math. So assuming that you're taking this class to move on to pre-calc, to move on to calculus, you're going to need this, all right? If you look on YouTube, you could find this formula sang to the lyrics of Pop Goes the Weasel. I will not disgrace anybody by singing that because that's terrible. But if you need to memorize it, there are several songs that this is put to. Please memorize it. That way you don't have to worry about this, okay? Write it down every time you're going to use it and then go from there. Okay, so we have negative 8, right, negative b, plus or minus the square root of 8 squared minus 4. A is, right, A is 1. And C, and you have to be careful about this because the signs, like they go with the numbers now as opposed to the formula. Sorry, divided by 2 times 1. Okay, if you're going to make a mistake, the 2 places you're going to make the mistake is forgetting the sign here, right, or here, and then forgetting this 2 times 1 down here. Okay, those are the places, either up here or down here. Those are the 2 places that mistakes happen. So be real careful when you're writing this down. Okay, so we have x is equal to negative 8 plus or minus the square root. 8 squared is 64. We have a negative and a negative, so that is a plus 4 divided by 2 times 1. Right? So this is going to be -8 plus or minus the square root of 68 all over 2. Okay, I'm sure that is a delightful looking number. Let's see. We could say something about 68 is equal to 4 times 17, I believe. 4 goes into 68. 1 time 28, there's 7. So 4 times 17 goes into 68. So what I'm looking for here is saying that 68 is equal to 4 and 17. Well, the square root of 4, that's 2. Right? So what you're doing when you're trying to find these, and it takes a little bit of intuition, it takes a little bit of practice, okay, is you're trying to fish out factors that are perfect squares out of this, all right, in order to make it a little bit easier, right? If I had to do square root of 18, 6 and 3 ain't going to help, right? Because neither 6 or 3 has a nice square root. But 9 times 2, right, is equal to the square root of 9 times the square root of 2. I can go ahead and take that as 3 square roots of 2. Okay, so it takes a little bit of practice to do this. One of the things about college algebra or intermediate algebra is they have a whole chapter on how to do this. And quite honestly, that is one of the chapters I would like to see us not really teach anymore, because the students spend so much time on it. And then the next section, we have to do it again. And they some of them get it. Some of them do a great job. But a lot of them, like there just isn't enough time to practice all of this, and they don't quite get it yet. So practice it is good for you, but at the same time, it's don't beat yourself up if you're not immediately pulling these things out. It takes time, it takes some practice. All right, so here we go. We have -8 plus or minus 2 root 17, all divided by 2. Here's the next place where people practice. They get so excited, like, oh, I've done it, and they cancel this, and they forget about this one. All right, so what I would recommend is saying, well, this is 2 times -4 plus or minus root 17 divided by 2. Right, I factored a 2 out of both of these terms. Now I can cancel. Okay, so our answer here is -4 plus or minus root 17. What was this? What was the question? Okay, I get it's hard because these are all long processes, and at some point you're like, what was I asking? So remember, this was the answer to the question. What are the x-intercepts? So the points, right? -4 plus root 17, 0, and -4 minus root 17, 0. Now, again, if you want to be a math teacher, okay, I know everybody wants to be. Root 17, it's a little bit bigger than 4 because root 16 would be 4, so this is a little bit bigger. So -4 plus something that's a little bit more on the positive side is going to be kind of a positive number, 0. And then -4 minus another 4 is like -8-ish, 0. So this is going to be like 0, 0, 0-ish, right? It's a little bit bigger, right? It's positive. Oh, wait, 0 plus. And this is -8-ish, 0. So when we go to graph it, you would have an estimate, you'd have a ballpark. I mean, it's 21st century, you guys have that at your beck and call. But, you're standing there in front of a bunch of the classroom, you're not going to quite have that. So it's nice to be able to estimate. All right, what was my vertex? My vertex, we already did that, right? That was -4, -17. All right, we got our x-intercepts, okay? Y-intercept is the same thing as what was, right? So y-intercept is, what do we have here? X squared minus 8x, what was it, -1? +1. Oh, -1. So we're just going to do is set x equals 0, and then plug it in. 0 minus 8 times 0, -1. All right, -1. So y-intercept is very easy. X-intercept, not so much. But we have the vertex, we have the intercepts, we should be all set. All the other stuff with, axis of symmetry, or domain and range, okay, all of that is very good. All right, so, all right, she's hanging in there. Okay, how about we try one other one? Okay, actually, I got a couple we could try. how about we do y is equal to 40 minus 12x minus x squared. We're going to run through the homework as well. So, you know, if you want to, if you wanted to like skip to that, you're not going to miss anything. Okay. So there's just extra examples. I don't know if your book does this to you or not, but you know, they wrote it in ascending form. So they mixed up the order. This is still A, B, and C, because the A goes with the x squared, the B goes with the x, and the C goes with the constant. So be aware that they can try to screw you up and write it in opposite order just to see if they can trick you. Don't let them trick you. I know you're smarter than that. Getting the vertex, right? X is equal to negative b over 2a. So this is going to be negative, right? Negative 12. So the negative part of the formula, and then we have the negative 12 here. Over 2 times negative 1. How many negatives we got? We got 1, 2, 3. It's minus, right? 12 over 2, 6. Now, we're just going to plug this in. We're going to say, well, when x equals negative 6, what's y equal to? All right? Or we could write it this way. All right? So, yeah, we have 3 cats. 2 of them, well, there's a team of 2 and a team of 1, and the team of 1 does not get along with the team of 2, so she is vigilant. Okay, so let's see here. We have y is equal to 40 minus 12 times, what was x? Minus, and then negative 6 squared. And again, I don't care what your calculator says. Negative 6 squared is positive 36. And you think, why do you always say that? Because I see this mistake all the time. Negative 6 squared. It's negative 36. It isn't. What the calculator thinks you meant was this. Okay, exponents happen before multiplication. So be careful. You are smarter than your calculator. Your calculator will lie to you, okay, if you let it. So this is 40. Negative times negative is positive, so plus 72. So 76 minus 36 is 36. Plus 40, we have 76 here. My vertex, negative 6, 76. Okay. This parabola opens down. So this is a maximum because the thing opens down. All right. Again, we could go ahead and find, okay, where do you think you're going? You're not touching my keyboard here, are you? You are. Okay. Can we move over here? We can. Okay. Beautiful. All right. So there we go. I've got one more really neat one to show you. Okay. We won't go through the X-Intercepts because this is going to be a long time. But let me show you one more, and let me show you a really neat trick if they give it to you this way. So I teach this way to my stats class. Okay. So we have x plus 5, x plus 4. What are the intercepts? Well, the intercepts, right? If I set the y equal to 0, right? We have x plus 5 times x plus 4 is equal to 0. X plus 5 equals 0, or x plus 4 equals 0. Yeah, I know. No. There you go. Okay. We might have to take it on a mission. Okay. Let's see. All right. You don't need to be in here. You don't need to be in here. Thank you. All right. Those are our intercepts. What's the average of the intercepts? Well, it's negative 5 plus negative 4 divided by 2. Hey, what's going on? We're taking an intermission. Hold on. Let me go stop, and I'll be right back. All right. Hopefully, I did the worst thing in the world I could possibly do, or I picked her up. So hopefully she'll be away for a while. All right. Nope, she is not. All right. We're going to pause and do. All right. Had to put the TA up. Okay. We were taking an average of intercepts. Sorry about that. And the average of my intercepts, right? The average of negative 4 and negative 5, right? is negative 4.5 or negative 4.5. That's your X value for your vertex. Okay, let's type it in. All right, so we have when X equals negative 4.5, what's Y equal to? Well, we have negative 4.5, plus 5, and we have negative 4.5 plus 4. So you're in debt $4.50. You pay back 5. And you're like, great, I've got half a dollar in my account. Negative 4.5, right? You're in debt 4.5. You pay back 4. Like you still owe them half a dollar. Multiply these together, and we get negative 1/4. My vertex is 4.5, negative 4.5, negative 1/4. Okay, 4.5 is also known as negative 9/2, right? Okay, 4.5, negative 9/2. All right, check this out. Let's multiply it out. All right, so we have x plus 5, x plus 4. All right. Multiply this out, we get x squared plus 5 and 4 is 9x plus 20. Okay, so if I want to know my x value for my vertex, right, x equals negative b over 2a. My negative 9 over 2 times 1. That's equal to negative 9/2, right? Or negative 4.5. Let's go ahead and plug in negative 4.5 into my function, right? So y equals negative 4.5 squared plus 9 times negative 4.5, okay, plus 20. Now let's see what we get. All right. So what do we have? Oops, we have negative, well, let's do it this way. We have negative 4.5 squared. See, I put it all in parentheses, so it'll give me the right answer. Okay, plus 9 times negative 4.5, okay, plus 20. Oops, there we go, just 20. Right. Negative 2.5, who would have thought? Right, that's negative 1/4. So my vertex is negative 4.5, negative 0.25. In statistics, the few times that we have to solve this, I think it works better because they're used to taking averages. For you guys, if you don't remember that, nobody will ever hold you, like nobody will expect you to remember this. But if you do remember and you end up with something like this, it's a cutesy little trick you can pull to not do quite as much work when you're finding everything. Okay. But yeah, there we go. And it's also a nice, if somebody deals you this problem, it's great because it's finding the X-intercepts. Okay, like finally, it's going to be as easy as finding the Y-intercept, right? For a change. So this is a nice way to deal somebody a problem. And if they are, they've done this before, they've seen it like this, then it's a much easier. This could be a very, very quick problem to deal with. All right. So I'm going to go ahead and stop there for this one. I'm going to come back and we're going to do some other problems. All right. So very good.